Thank you, Boris, and I thank you, organizer, for inviting us to this fantastic town and fantastic country. I would like to convey the best regards of Antonio Logrieco and Visconti, which are the coordinator and director of my institute, the coordinator of the project and the director of my institute, and they would love to be here, but many duties keep them far from this very important point. I'm going to talk, to have this presentation instead of Antonio Logrieco, which is the coordinator of this project. And I would like to emphasize how this project, MYCORED, has the main aim at developing strategic solutions to reduce contamination by mycotoxin or major concern in economically important food and feed chains through MYCORED research joint actions. The project has been built on the outcome of several European projects from the frame from frame 5 to the frame 6 on mycotoxins by supporting, stimulating and facilitating education and cooperation with countries having major mycotoxin concern related to international trade and human health. And this is proved by the direct involvement of some ICTS countries like Argentina, Egypt, same Russia, South Africa. There are international organizations such as CINIT and IITA, together with strong scientific alliances with international experts strengthen, and all this strengthen the project through sharing experiences and resources from several past ongoing mycotoxin projects in a global context. So, the novel methodologies, efficient handling procedures, information, dissemination, and educational strategies are considered in a context of multidisciplinary integration of know-how and technology to reduce mycotoxin exposure worldwide. And these are just examples of the projects which were in the previous framework and then were dedicated to mycotoxin. Many participants of this project are now in MYCORED. MYCORED addresses the problem of mycotoxins at global level, aiming to first develop novel solutions, drive the methodologies, and handling the procedure to reduce both pre- and post-harvest contamination in selected feed and food chains. And a second very important point is to generate and disseminate information and education strategies to reduce mycotoxin risk worldwide, and then create a wide interest among players and international network. It's important to underline that high-risk areas of Africa, Asia, and Latin America have been receiving in these 2 years and will receive major attention by cooperation with international agricultural and food organizations, and by applying the results of all technical work packages as well. The budget of MYCORED is quite high, is over 7 million euros, and there are 25 partners for 17 countries. And the period will be 4 years, so we are the second. We just ends the second year of the project. Right now, we have to run for 2 more years. The structure of MYCORED is organized with we will call 5 horizontal work packages on planetary system, biocontrol, predictive models, transport, storage, and landing, and food processing. And the application is to the main food chains, maize, wheat, grape, and rye, with the main mycotoxins causing concerns, phimolysis and aflatoxin for maize, mycotoxins and ocatoxinase for wheat, ocatoxin A for grape, and aflatoxin for dry food chain. There are then two, let's call vertical work packages which deal with the detection of toxigenic fungi and with the analytical tools for mycotoxins. Finally, there are two work packages. One is management, but the most important is the information, education, and demonstration, which is very relevant in the MYCORED program. And the structure of the project is done in a way that all steps from field to the consumers can be covered by this project at the different level of the food chains: field, storage, processing, and transport, processing, and storage and consumption. Going to the first results of these 2 years, for what is concerned the first work package, the pre-harvest, this shows a significant number of cultural genotypes were compared for susceptibility to infection, to the infection of Fusarium causing egg bites, and the oxynivalum, using 3 different inoculation methods in wheat and maize. Examination of the resistant genes, the QTLs, in wheat and maize for identification of resistant traits, and microarray methodology was used for examining the interaction between host and pathogen between maize, especially, and Fusarium verticillioris, which is the main producer of the carcinogenic phumosins on maize. As a pre-harvest, there was, as results, a better nozzle composition was developed with a 50% additional fungicide reduction. This compared to the best existing technology. As always, all the results of work package 1 in pre-harvest, there's been, here we can show the effect of Prosaro fungicides on Fusarium road of maize. You can see in the third line, with a very efficacy in controlling the maize ear rot. And as further results obtained in this package, there has been the infection by Fusarium verticillioris was studied to show the induction of genes which participate to the let's say interaction with Fusarium verticillioris, and in resistance maize, most of the genes can provide the basal level of defense of the fungus prior to infection, while in susceptible maize, most of the genes are induced after infection. So, about 240 late genes have been characterized in this work package at the moment. As synthesizing this work package data, we can say that by using Prosaro, the disease has been, the Fusarium life has been deeply controlled. There has been an improved fungicide technology, and there is a very good agreement between different inoculation methods in wheat. As an unusual result, also there is a positive correlation between Fusarium erode resistances. Go to the work package 2, which deals with biocontrol agents. There have been there is the study of the commercialization on the large scale of BCA, the biological control agents, and this study of the economics of using these biocontrol agents has been completed. There have been field trials in Italy, Netherlands, Nigeria, and Argentina performed with the biological control agents in wheat, maize, and peanuts. And as most important results, in Nigeria, between 69 and 80% of toxin contaminating maize was reduced by using a non-toxigenic strain 64 maize fields were analyzed, 8 peanut fields, and all these fields were treated with afrasafe, and we can say that this product was showing to be very effective in controlling the aflatoxin contamination. In Netherlands, the wheat stubble treated by biological control agent were reducing contamination for 70% of the Fusarium species which were inoculum for the following year. So also in this case it was a very good results. Field trade done on 2010 by using Bacillus species and Brevibacillus species antagonists to control Fusarium gregorianum on stubble. Wheat stubble was performed in Argentina, and also there were trials in order to control Aspergillus flavus on maize, and also a field trial to control Fusarium gregorianum on wheat in the field. Also, this result, the previous result performed in Argentina by using biocontrol agents, were for the reducing the attack of Fusarium gregorianum very efficacy. So, at the end of these 2 years, we can see that we have very promising selected biocontrol agents for controlling Fusarium egg-like attack and aflatoxin contamination of maize. And also in Nigeria we have excellent results in controlling on peanuts and maize the possibility of aflatoxin contamination. As a third work package, the modeling in pre-harvest, standardized data systems in place are for cropping system, location, meteorology, analytical data for model validation, and development of risk maps. The oxygen with data collected in MYCORED has been used for validation of an existing model, and a database has been developed prepared containing all available relevant information for modeling development for Fusarium verticillarius and phimolycins, Aspergillus flavus and aflatoxin, both in maize, and for ochratoxin in grapes. For the Fusarium egg-like and wheat, a predictive model for the oxygen contamination in small grain has been validated in all countries involved in the project, and valuable predictions were confirmed. Fields with the oxygen contamination over the legal limit were correctly predicted, and now also models for ochratoxin A in grape and Fusarium erot on maize are under constructing, and this is an example of a map of risk of the oxygen contamination worldwide, and also further risk maps drawn for the risk of mycotoxin contamination in different crops are in developing. In particular, as I told you before, maize and phimolycins, maize and aflatoxin, ochratoxin and grapes, peanut aflatoxin, and also pinaceous nuts for aflatoxin. As a methodology for post-harvest, relationships between environmental factors and dry nectar loss relevant to EU legislative limits for the oxygen, phimolycin and aflatoxin have been identified in wheat, maize and hazelnuts. The first examination of the in vitro effect of ozone on germination and growth on relevant mycotoxin producing fungi has been initiated, and actions to reduce mycotoxin contents in agricultural byproducts and commercial products have been performed, testing in vitro the ability to bind simultaneously at the same time aflatoxin B1, ceranum, phimolycin B1, ochratoxin, and the oxygen value.